Hello, mentors. Let's talk about reasonings for meeting 3. Before, let's look where we are. So meeting 3 will have 2 parts, more counting and then the game of set. And then in this part, more counting, which is quite short, just 20 minutes or so. Let's talk about the first activity, which is called reasonings, in which students analyze correct and incorrect solutions. So let's remember that you already did counting in meeting 2, and so this is a natural follow-up. So the way it starts is by showing the first page on the student workbook where you recall the Fiesta de Músicos. And maybe you have some new students, so be aware of that. But let's just assume that all your students already attended the meeting before, then this would just be a quick review. This question is important. Do you recall how many músicos, different músicos are there? And so they should know that there's 81 and know how to reason about it and how to justify it using possibly the tree. So if you did not come last week, you may ask someone to explain it to you. So this activity is very nice. There's this tip on voice to allow students to really participate in deciding the flow of this activity. Because what if many new students, right, that didn't come, maybe you can decide then to count again the músicos, but maybe led by some students, so empower them. Maybe you feel that most students are really solid in counting and this activity won't add much, these reasonings, so you can totally move on to number 2, to the next activity. But maybe keep these cases just in mind, so maybe you have very few students that still struggle a little bit, so you can actually discuss these cases maybe privately with them. So just adjust. What if students want to create a similar situation? Then go for it and open up the activity. So this is the 1, 2, 3, the quick in a nutshell of these reasoning. So first, connect with meeting 2. It really depends on where you ended up. This is also a great way to test for understanding about counting. So this feels a little bit like a quiz or like a test, and I think that's all right because it's still conceptual and it's just a good thermometer for you. And then, as we just said, you can move fast if students seem to be really understanding things well and move to more creative things in activity 2. So let's take a look now at the situation. So these are the reasoning. So these are the mathematical questions that your students will look. You can follow this natural order, but you can also maybe start in any of them depending on your students. Okay, let's look at June, what she says. So these students says the following. The total number of músicos is 3, the gift, plus 3, the body, plus 3, the haranas, plus 3, the face. We need to add because all the options are different. So I get 4 times 3, or 12 músicos. I think what would be valuable, and it's also just some attitudes about math, is not just say that June is wrong, just flat, but in which cases would she be right? Which would be a case in which we would really be adding. So that opens up to new situations or possibilities. And of course, there are where you would actually add the options and not multiply. So this gets you a more solid understanding on why you are multiplying in this case of the trees, and then think about situations in which you would be adding. For example, if there's just one choice overall, one aspect, but you have 3 options in one category, 3 options in another category. Like think drinks, you have maybe 3 sodas, or you can pick between 3 milkshakes, or you can pick between 3 other type of drinks. Then you would be adding because it's just one aspect, right? It's just one choice and they're all at the same level, right? Once you pick one, you're done. So this is not the case in the trees. And then this would be a very nice, discussion about that. So what we would do is actually let's first show the tree as in the last meeting. So hopefully you can refer back to this tree and have it ready. Important for students to understand that the order doesn't matter. So you could start picking the face and then picking the head. Then maybe the choice of harness, the guitar, and lastly the gift. And that's a tree, but you get the same count, just different. It's a different, way to arrive to the final result, but you get the same options in just different orders. If you start with picking the head, say, or picking the gift first. So this flexibility, it's nice because it can help in reasoning for visual reasons that we will explore. So that's one important thing to know. And then hopefully, yeah, you remember that you are really multiplied because each choice opens triplicates, right? Because it's partial choices. We're building this musico in 4 layers in whichever order. And so it just multiplies, right? There's a lot of possibilities, which kids, did lists in the previous meetings or tables and realize that. So that's June. That's the value of June. Don't just, invalidate her, but actually she would be right in another situations. So it's good. It's great. Let's talk about Mario. So Mario says, okay, I wanted to know how many musicos are not human. And notice that in these reasonings, we don't put the 81. We could have put it, but we don't put it on purpose so that hopefully the reasoning is more general, regardless of the total equals to 81. It's a reasoning. Of course, students may bring the 81 in the discussion, but somehow you want to take it away a little bit so to push towards generalization, in the sense that this tree may be a different tree with other numbers of options in an aspect or different numbers of aspects, and the reasoning would probably be the same. So Mari wants to count the non-human musicos. So he says, I first found the total of musicos, then I subtracted 1, as we don't want the 1 human. So the total is, the answer is total minus 1. So some students may agree, some students may disagree, and there's going to be a discussion. But I think the key is don't just have this discussion without any reference to representations, but actually push students to show the reasoning, not just explain it, but actually show it in the tree or with the tiles or with the cards, with examples, etc. So here we could ask Mario, and again, it's not about saying, Mario, you're wrong, next student, but actually, okay, we actually, we actually value that you are subtracting because you are counting something that is not. So it's a good idea to subtract. So we validate Mario partially, one part of the solution. The approach is good. And then we start discussing with Mario. We would ask Mario, why 1? Why did you subtract 1? Where is the musico in the tree? Where is the only human? And hopefully Mario realizes that there's lots of humans. And here comes the flexibility that hopefully would start. And so remember, human is here, the face, right? This is the human. So hopefully we would say, okay, let's suppose that we built the tree in such a way that we started with the head. Oh, sorry, here is face and head, it's body, sorry. Let me just correct. So let's say we started with the head, and you can just write it in your tree. And then we don't really care much how we continued. And so we could bring maybe the human here and just say, okay, let's actually, do it here for Mario. What do you notice? And hopefully Mario says, oh, okay, there's 1 human at level 1. if we just had this first tree of the first level. But then since I remember that it triplicates when choosing gifts, and then it multiplies by 3 again, so by 9, by choosing the body. And then by picking the choice of haranas, 0, 1, or 2, each option triplicates. So it's a lot of replication. So he'll see that, okay, one way to see it is that there's 27 humans. But the other way is to see that it's 1/3 of the total. So then it's going to be the total minus 1/3, or when doing fractions, 2/3 of the total. And again, some students may just say that the answer is 81 minus 27, but you hopefully push them to other ways, more abstract, that the answer is in terms of the total. So 2/3 of the total, or the total minus 1/3 of the total. So that's correcting Mario. And let's move now to Johanna. So, and again, you don't have to do all 4 challenges, right? It takes some time, and it will really depend on your students. So even if you do 1 or 2, it's fine, as long as you have a deep reasoning discussion. Joanna says, if there's only one option for the gift, so the bread, let's say, then the new total is 1/3 of the old total. And again, this flexibility of the trees, understanding that these being independent options really doesn't matter which order we pick. You're going to get the same result. So it would be great to start with a gift. It's just to visualize it in an easier way. It's not that you have to build the tree that way, but otherwise counting, visualizing where these musicos are, it's a little harder. So we just have one option of the bread. So really we don't pick here, delete. Oh, sorry, let's just delete this here. And we don't have the chocolate or the dahlia, we just have the bread. And so in this world of possibilities, you don't have access to these partial trees, to these branches. So you forget about them. And so you see that the new total, it's exactly 1/3. You just see it right away, right? Because I deleted 2 equal copies of what remained, equal in size, right? So that's one way that you would see. So Joanna's right. And then a good question would be along the lines of show me these 27 musicians. And so maybe they would hide the gift, or don't show the tile, and yeah, just realize that it's less options. Another way that students could go about is 3 times 3 times 3 divided by, right, the total, which is some not as abstract way, but still nice, because you would be canceling 1, 3. So that would be 1/3. Okay. And then we're learning things, right? We're learning that choosing one option, we don't even need to draw the tree, the level of the tree. So we just get a tree that's really simpler with just 27 options, total options. Finally, let's do Mary. And then this gets a more complicated tree. Let's see, we get 2 more face options. Let's say a perro and a rana. Then the new total would be twice the old total, which kind of makes sense, or at least sounds great, right? Sounds like a reasonable hypothesis, because you have 2 more options, and we don't like to add, we like to multiply. So maybe that's the answer, twice the old total. And again, it's all going back to the tree. How would you make sense of 2 more face options? And so let's call this, sorry, yeah, let's call this face is the same as the head, so this will be the body. Okay. So this would mean that my tree has two more branches at the beginning. So we could call it something like a, let's see, like a 5, then 3, 3, 3, 3. Whereas before we had a 3, 3, 3, 3, 3 in terms of the splitting rate. And so what's nice is that we can still think that, let's put some hearts here. So we don't even need to draw, but just describe what we would do. And I think that's an interesting, like a very important thing in mathematics. Don't do it, but describe what you would do. Here, you would still need to pick the body, the gift, the harana. And you would get a number that would be equal to the options in these other hearts, right? So we get this symbol without drawing these mini trees, these mini parts, that makes us realize that it's actually 5/3, right? Of the all total. So to correct Mary, what we get is that the new total since the old was like 3 hearts, right? Somehow the new is 5/3 of the old. So it's not twice, but 5/3. And again, some kids may have trouble understanding this, so you go back to the concrete case and say, it's like you have 27, 27, 27. Now you have 27, 27, 27 plus 2 27s, and go from there to see why this would be 5/3, right? You could also say it's the old plus 2 times the old. 2/3, sorry, times the old. And that gets you 5/3. So you get some algebra here. And that hopefully shows all this flexibility in thinking about trees, all these ideas that the trees are just flexible, and we can reason with trees without necessarily needing to draw all the final branches, the final nodes, all the paths. We can just pretend we did it and put some symbols maybe to make sense of what we're thinking, right? So lots of other options. A student may ask, let's say you could have a student, let's put it here, asking something along the lines of, I have 2 more aspects with 3 choices in each. So it's kind of generalizing or extending these musical things. What happens to the new total? And it's not what's the value, but how does it compare to the old total, right? So new equals what? Sorry, in terms of old. And again, you could try to reason like this. Let's call these 3. This is great. This is a very big tree. Let's call it the sun. So we know that's 81 choices. And if you have 2 more aspects that, of course, are independent, then you could think something like this. you could say, okay, the first aspect, new aspect is here. Let's put some yellow. It's a new aspect. Maybe the color of the, the shoes or whatever you like. Right? Now there's three options. Then you would have another second aspect, another three options. And then you have all the aspects. So it's like copying these three in each of these nodes, right? In each of these partial nodes. I'm not done with the musician, right? I just decide. But if we do that, we really run out of time. So we just make reference, right? And we're doing algebra without variables. We're thinking very generally. So what we say is you're getting 9 sums options. So it's a lot. But then we just see that the new will be 3 times 3 in terms of the old, right? So 9 times. So it just explodes, right? It's a lot, even if we just have 5 aspects in total. Okay, so hopefully this gives you solid understanding of this activity about reasonings. Let's just remember that be flexible. You don't have to do all 4 of them. There's a game in part 2 to be played. So just, you have a lot. Just use whatever it's good for your students. Thank you. And see you in a future video.